Good afternoon, everyone. My name is Cheyenne Smeaton, and today I will be presenting to you about the climate enforcing factors. In this presentation, we are going to discuss forcing agents in climate change, positive and negative feedback mechanisms, post-climate change, and modern climate change, as well as the impacts of climate change. On the right-hand side, you can see the security implications we have from climate hazards to primary impact to the secondary impact. The climate hazard is more drought and more flooding, whereas the first primary impact would be reduced water supply and critical assets inundated. And the secondary impact would be agricultural production reduced and infrastructure damaged. First, we are going to discuss the forcing agents for climate change. The forcing agents can either be natural or human-made. The natural forcing agents include changes in the sun's energy output, a regular change in Earth's orbital cycle, and large volcanic eruptions. The human-made forcing agents can be anthropogenic, climate drivers like heat-trapping gases, and changes in land use that make land reflect more or less sunlight energy. As you can see on the right side of the slide, we can see an illustration of the climate system. The sun and volcanoes seem to be on the outside because they are forcing agents. Some important information to understand before we move on in the presentation is positive and negative feedback, as well as climate change and forces in climate change. There is an excellent example provided on the slide that represents how positive and negative feedbacks relate to global warming and greenhouse gases. A positive feedback is in climate change. A positive feedback accelerates a temperature rise. The negative feedback slows down the temperature rise. Climate change references long-term temperature changes and weather patterns, and the forcings in climate change are natural drivers that put light-reflecting particles into the atmosphere, like volcanic eruptions, sun's radioactive output, most anthropogenic changes in greenhouse gases, and the tropospheric aerosols. On this diagram, you can see that positive feedbacks relate back to global warming, and the negative feedbacks relate back to the greenhouse gases. The greenhouse gases from the positive feedbacks can be from water vapor and methane, and the negative feedbacks would be carbon dioxide. Two examples of a forcing agent for climate change would be greenhouse gases and solar radiation. Both of these examples are natural drivers that put light-reflecting particles into the atmosphere. The greenhouse gases will absorb the energy that radiates towards the Earth's surface, which re-emits heat and lowers the temperature of the atmosphere, which will warm Earth's surface. Since this produces a warming effect, this would be an example of a positive forcing agent. Solar radiation. This means Earth is receiving more incoming energy from sunlight compared to how much energy is being released into space. So this counts for why our temperature is increasing so much and so rapidly, especially over the years, and we will talk about that later on in the presentation. The past climate change example I decided to choose was the Little Ice Age. The Little Ice Age was from the year 1300 to 1850 CE. Temperatures in Europe, North America, and Asia dropped significantly, leading to the expansion of glaciers and sea ice. Volcanic activity contributed to the event. They produced large amounts of sulfur dioxide into the atmosphere, which can collect with water vapor to create sulfate aerosols. The aerosols reflect incoming sunlight back into space, leading to cooling temperatures. Several large eruptions during that ice age did occur. Changes in ocean circulation led to the Little Ice Age. Changes in circulation led to a decrease in the amount of warm water transferred from tropics to higher altitudes. The other example of a past climate change event that I chose was the formation of Kansas. The formation of Kansas was between 2 to 3 billion years ago. Kansas belonged to a supercontinent known as Rodinia. 750 million years ago, the supercontinent separated. Climate altered as the landmass dispersed. Geological history of Kansas shows the effect of climate change. The climate changed in order to force the continent into adapting after relocating. The frequency and severity of extreme weather events are predicted to increase in Kansas as the state's average temperature rises. In this slide, you will see a graph with data points from 1880 to 2020. This gives researchers the ability to assess the change in temperatures over a long period of time. When we see annual mean increasing each year, then we can tell that the climate change has been increasing each year will affect the world on a global scale. So in this, we can see that the average increase is about 1.6 degrees Fahrenheit annually since the year 1880. It's continuing a long-term warming trend due to human activities. The year 2020 is statistically tied with 2016 for the hottest year. So this means that the last data point was in 2020. Since the last data point was in that year, that is the highest and equaled out to the year 2016. So that doesn't mean that we are necessarily staying at a same rate, because we are still increasing with other factors involved. So you can see next that in this graph, it is of New Bedford, Massachusetts. This is the closest location near me that has tracked the annual average temperatures for at least 100 years. According to this graph, we can also see that the annual average temperatures has increased over the many years. In order to obtain this graph, I used a link that was provided to us from our professor. From there, I was able to select a location under NOAA. That was close to me and had been tracking temperatures for at least 100 years. This website is open to the public, and with a little bit of searching, I believe you would be able to find it, which is helpful for the general public. It's exceptionally helpful for the general public to be able to view the increase in temperatures, because this will get more people rolling on to change climate change, and in order to put out more policies and more regulations because of the general public wanting that. Environmental impacts from climate change can be seen all around the world. Climate change is affecting many things like species survival rates, weather, and human health. In Massachusetts, an example of an environmental impact that has been caused by climate change is the Massachusetts southern shoreline will experience increased amounts of flood and erosion. Roads will disappear and homes will be destroyed. The South Coast salt marshes are shrinking and disappearing due to rising sea levels. Salt marshes will filter water, offer wildlife habitat, and act as a storm buffer to the communities behind them. I wanted to provide this graph because it is a great example of an environmental impact. Sea levels are rising due to glacial melt. In this graph, the audience can see that in the 1900s, the sea level was roughly negative 0.20 meters, and in contemporary time, the sea level has risen to roughly 0.1 meters. There are many socioeconomic impacts caused by climate change. Here are a few examples that are located in Massachusetts. The critical infrastructure is threatened, the man-made harbor barrier is being threatened in New Bedford and the town of Fairhaven due to rising sea levels. Causing the barrier gate to close many times throughout the day is not beneficial for the fishing industry. The economy is impacted because the infrastructure will need to be replaced or rebuilt, costing more money. All of the homes that will be destroyed will displace people from their belongings and money, forcing the state to help with costs for these vulnerable people. Jobs are also threatened due to the port not operating efficiently. Located in downtown New Bedford, downtown New Bedford is home to many jobs and generous revenue for the city. There is a quote from an article that I did like to incorporate, and it states that the Port of New Bedford, for instance, supports about 39,000 jobs and generates about $1.8 billion in total personal wages annually. If the port can't operate, those jobs go away. And that is a very important thing for people, especially in my area, to understand, because without that natural barrier, when storms arise, all of the roads would be flooded, all of the buildings and infrastructure would be destroyed, which is why the harbor barrier does need to close at certain levels, but it's due to the climate change that this is occurring. And we may see in the future that this gate is closing even more frequently, and that the jobs may be impacted because climate change is not rapidly reversing anytime soon. And it's hard for humans to reverse climate change anytime soon because we need certain geoengineering and mitigation in place. Geoengineering is the manipulation of a certain environmental process that changes the Earth's climate. This is accomplished in an attempt to combat the effects of global warming. Mitigating climate change is the action of reducing the amount of greenhouse gases that are trapped in the atmosphere. Two great examples are ecosystem restoration and solar radiation management. Ecosystem restoration is when restoring ecosystems we can naturally remove carbon dioxide from the atmosphere and oceans, reverse global warming, reduce ocean acidification, conserve biodiversity, and restore lands. Solar radiation management is when the reverses of global warming by reflecting sunlight. We can reflect the sunlight back into the atmosphere. The future climatic changes and limitations will depend on how well and how fast geoengineering and possible mitigation of climate change can occur. Some of the predictions are that sea levels are expected to rise 2 feet by the year 2050 along the south coast. Increased amounts of floods, about 28 miles of roads and 1,600 buildings are to be affected. Daily tides in Westport, Massachusetts could flood 104 buildings in town. Beach erosion is expected to worsen. 23% of the salt marshes in the region could be lost by 2050. In Dartmouth, 86% of the salt marshes could be lost to flooding. Westport's salt marshes would endure 48% of salt marsh acreage at risk of disappearing. The limitations to the predictions is the complexity of weather in New England. Massachusetts specifically has a combination of weather impact factors that can change it in minutes. And due to the uncertainty of the weather patterns in the state, we cannot predict for certain how climate change would affect the state in the future. However, based off of past history, we can see that if we do not change anything, then it will worsen. For example, in my personal experience, I have endured the beaches eroding away the roads in Westport, Massachusetts. So when I was growing up, there was an example and an experience in a year where there was a huge hurricane that caused the roads near the beach to be fully blocked off because they had been eroded. And it took a long time to build those roads back. In this graph, the audience can view the observed and predicted climate temperatures of Massachusetts. You can see that the data starts at a little before 1960 and continues until a little after 2080. We can see at least a century's worth of data on this graph. This allows researchers to predict future temperatures based on patterns they see. In conclusion, in order to wrap up this presentation, I hope you enjoyed learning about the future agent for climate change, the difference between positive and negative feedback mechanisms, modern and past climate changes, the socioeconomic impacts created from climate change, and the geoengineering and mitigation techniques that can be used to combat climate change. After hearing this presentation, my goal is to help the audience understand climate and forcing factors better. Lastly, I did include a little illustration on the left-hand side, and these are solar climate intervention methods, and this I thought is a great example for the audience to view when we are ending the presentation. Thank you, and I hope everybody has